To start, place your digital scale on a level surface. Press the power button and wait for the display to stabilize at 0. If you are using a tray, place it on this scale first and hit the turn button to zero out its weight. Now gently place your item like this bullet casing onto the center of the platform. When you are done with your measurement, simply press the power button to turn the scale off.
First, we will number the paper from 1 to 3. This is where we will write the measurements we get using the trigger puller. Before starting, make sure that firearm is unloaded. Check the magazine and chamber. Next, we prepare the trigger puller to use it. Attach the hook or gauge to the trigger, making sure it is positioned straight and secure. Now we start with attempt number 1. We slowly pull the trigger using the trigger puller until it breaks. Our first measurement is 3.6 ounces. We will write this under number 1. For attempt number 2, we repeat the same step. Attach the trigger puller, apply slow and steady pressure, and wait for the trigger to break. Our second measurement is 3.9 ounces. We will write this under number 2. For attempt number 3, again we use the trigger puller the same way, slow, steady pressure. The final measurement is 3.8 ounces. We will write this under number 3. Now we get the average of the 3 attempts. The average trigger pull weight is 3.77 ounces. That's how we measure trigger pull weight properly using a trigger puller. 3 attempts for consistency, accuracy, and safety.
Today, we demonstrate the proper procedure of measuring the trigger pull weight of an unstrung pistol using a trigger pull scale. First step, the trigger pull scale is carefully attached to the trigger and steady straight pull is applied until the trigger breaks 3 pounds. It is 3 pounds. For the second test, the scale is to reset once again. A smooth and consistent pull is applied, producing a result of 3.2 pounds. And the third one is the final test. The same procedure is repeated, and the trigger breaks 3.1 pounds. To determine the average trigger pull weight, the 3 results are added and divided into 3, and the total average is 3.1 pounds.
As the gauge is inserted, we look for the point where the taper fits snugly firm but not forced. In this case, the measurement clearly shows a result of 9 mm.
In forensic science, the microscope is a key tool for uncovering hidden details. What you see here is a comparison microscope used in ballistic to examine 2 pieces of evidence side by side. The sample is placed on the stage and adjusted with precision knobs, while light reveals details that our naked eye cannot see. Through the eyepiece, the examiner views magnified striations and impressions, unique markings left by every firearm.
Trajectory box is used to visualize the possible path of the bullet. Dowels are inserted into the bullet holes to represent the bullet spot. The angle finder is a tool used to measure the vertical angle of the bullet trajectory. This tells us if the bullet traveled upward, downward, or straight. To use it, first insert the dowel into the bullet hole to represent the butt of the bullet. Then place the flat side of the angle finder against the dowel. Make sure it is steady and properly aligned. The number shown on the scale is the vertical angle of the shot, which helps determine if the shooter was positioned above, below, or level with the target. The protractor is used to measure the horizontal angle of the bullet trajectory. This shows whether the bullet traveled to the left, right, or straight forward. To use it, place the protractor flat on the base of the trajectory box. Align the center point of the protractor with the base of the dowel. Make sure the zero line is facing forward. Then observe where the dowel lines up on the curved scale. The number you read is the horizontal angle, which helps identify the shooter's position across the scene. The trajectory box, dowels, angle finder, protractor, and bullet hole measurement work together to accurately reconstruct the path of the bullet. These tools help investigators determine the shooter's position, direction, and firing angle. By using proper measurement and visualization, the findings become more scientific, reliable, and acceptable in court.
As we wrap up our discussion on firearm identification, we are reminded of how essential this field is uncovering the truth behind every firearm related incident. Firearm identification provides investigators with scientific answers, revealing what type of firearm was used, its condition, its behavior during firing, and whether it can be linked to a specific bullet or cartridge case. This discipline strengthens criminal investigations and supports the pursuit of justice through evidence-based conclusions. The accuracy of firearm identification relies heavily on the proper tools and equipment used by forensic examiners. Each device serves a unique purpose in ensuring that every analysis is precise, objective, and scientifically defensible. Tools such as the comparison microscope, stereo microscope, and digital imaging systems help examiners analyze microscopic markings found on bullets and cartridge cases. Measuring instruments like vernier calipers and micrometers provide exact dimensions, while bore lights and bore scopes allow examiners to inspect the condition of a firearm's barrel with clarity. Equipment like the firing box and water tank ensures that test bullets are safely recovered for comparison without damaging their identifying marks. The chronograph measures bullet velocity, while cleaning rods and maintenance tools allow for safe and proper handling of firearms before examination. Specialized kits for gunshot residue testing help determine whether a person fired or handled a weapon. Even more advanced systems such as IBIS, the Integrated Ballistics in the Identification System, allow investigators to compare ballistic evidence with entries nationwide, linking cases that might otherwise remain unsolved. Tools like balance scales, bullet pullers, and ballistic gel blocks support deeper analysis of ammunition characteristics and bullet behavior.
Advanced systems like IBIS help investigators match ballistic evidence nationwide, while tools such as balance scales, bullet puller or bullet scale, ballistic gel, and trigger pulse scale provide precise data on ammunition and firearm behavior. These instruments reflect the accuracy and scientific discipline behind modern forensic ballistics. They allow experts to uncover details beyond what the eye can see, ensuring conclusions are based on solid evidence. Thank you, and may we continue upholding proper techniques, reliable tools, and scientific integrity, because in the search for truth and justice, every detail counts.